For the chapter on the lymphatic and immune systems, there will be two parts to look at the lymphatic system itself, and then we'll look at the immune system and the immune reactions. So here we're going to start with the lymphatic system and concentrating on its role in circulation. The lymphatic system has three main functions. First, to drain excess interstitial fluid from tissues, and from that, really, the other two carry on. One is to transport dietary lipids, so as interstitial fluids are drained from digestive tract organs, lipids are taken into the lymphatic system. And then it also carries out immune responses. And again, as interstitial fluids drain from various tissues, it provides a location for immune responses to be initiated and fight off possible infections. To look at how the lymphatic system plays this role in draining excess interstitial fluid, let's take a second to step back to the end of the vasculature chapter and consider what's happening as blood passes through the capillaries in all of our tissues. In this picture from the vasculature chapter, we can see what drives movement of nutrients out of the blood and into tissues and wastes from tissues back into the blood. It's all based on the change in pressure across the capillary bed. At the arterial end, blood pressure is at 35 millimeters of mercury, and by the time we reach the venous end, it's dropped off to 18 millimeters of mercury. All throughout the capillary bed, the blood pressure is countered by the colloidal osmotic pressure pushing water back into the blood. Since the blood pressure is higher than the osmotic pressure on the arterial end, the net flow is out of the blood, filtering things out of the blood. And since the pressure is dropped off to the venous end, the osmotic pressure is higher, and the net effect is to reabsorb materials from the tissue back into the blood. Mostly we're talking about the movement of water. With the water moving out during filtration, come the nutrients, and with the water coming back in at reabsorption come the waste products from that tissue. The thing is that the two pressures are not equal. There's more pressure pushing things out at filtration than pulling things back in at reabsorption. And because of that, excess water comes out of the blood that's not reclaimed, and that's where the lymphatic system comes in. Now, in considering the water movement from the blood into the tissues, it's important to think about what we call that fluid that contains the water. When it's in the blood, we call that plasma. When it moves out of the blood, it's interstitial fluid. And when it moves into the lymphatic system, it's lymph, or lymphatic fluid. Now, these are not equal fluids, or equivalent fluids. Plasma contains a number of different things that don't get filtered out of the blood. Most importantly are the plasma proteins. Interstitial fluid, however, is completely taken up by the lymphatic system. So interstitial fluid and lymph are really the exact same thing. Now, another term to introduce, it'll come up eventually, is chyle, which is a special name for lymph when it has lipids in it. And remember that one of the functions of the lymphatic system is to transport dietary lipids. So when there are lipids in the lymph, it has a special name. In considering the lymphatic system and its role in circulation, we want to look at those organs in the system that are specifically part of that circulation. There are several different types of lymphatic vessels. The smallest are the capillaries, which we find worked in with the blood capillaries in all of our tissues. And then lymphatic vessels are just the average size vessels. And the largest ones are called ducts or trunks. Maybe trunks are larger, but there's a little gray area in between the two. There's also the cisterna chyli, which is a sort of holding area for lymph, especially that contains lipids, hence cisterna chyli. Lymphatic capillaries are worked in with the blood capillaries in all of our tissues. They will return the water that's lost from the circulation from the blood at the capillaries back into circulation through the lymphatic system. And the way that interstitial fluid gets into the lymphatic system is really quite elegant as being a passive process. There are collagen fibers anchoring flaps of the endothelium of lymphatic capillaries to the surrounding tissue. As that tissue starts to fill with water, as it swells, those flaps are pulled open, water moves into the lymphatic capillary, and as the swelling goes down, the flaps close again. The lymphatic capillary then allows the water to move on. It passes through a valve that'll prevent backflow, basically draining the water out of that capillary. And the next time the water causes the tissue to swell, the flaps will open up and the water will move into the capillary. The movement through the lymphatic system, we'll see a little later, is dependent on other passive mechanisms. Here we see it happening just as water fills a tissue, the walls, the lymphatic capillaries open up, water moves in and it moves on, and new water will come in and fill in that space. This figure has been modified from the one in the book by a little bit to correct a couple of problems. First off, the book has the cisterna chyli and the thoracic duct going up from that colored in blue when they should be green, because green is the color that we associate with the lymphatic structures. Also, I've added in the label for the cisterna chyli here. The inset for the lymph node from the picture in the book is not correct. It's showing actually what you'd see for lymphatic capillaries in the tissue in any part of your body. Instead, the lymph node should be representing reticular tissue. So I found a micrograph of that to represent that inset. It's not a perfect inset for this, but it's more accurate than what the book has. In this figure, again, we're seeing in green the lymphatic circulation. There are vessels coming from all over the body. We don't see the capillaries themselves because they'd be microscopic and relative to this view. And there are lymph nodes scattered throughout all of lymphatic circulation. They are concentrated around joints. So they're axillary, inguinal, cervical lymph nodes. Those are the major clusters of them around those major joints. But you're also going to see some around the elbows and the knees and the ankles and the wrists, just in various places where there's a good bit of movement, because the movement will squeeze the lymph nodes and help to push fluid through the lymphatic system. When we look at the lymphatic organs later on, we'll see how lymph nodes ensure that the fluid only moves in one direction. And besides being squeezed at the joints, they also will help to increase the pressure of fluid moving through the system. Eventually, everything comes back to the subclavian vein. Now, in the next picture, we'll see that there's some asymmetry in that drainage of fluid because of what's happening from the cisterna chyli down. Drainage bilaterally in the lymphatic system is not equal. From the cisterna chyli up, the right side drains to the right subclavian vein and the left side drains to the left subclavian vein. But from the cisterna chyli down, everything in the lower body drains to the left side. Now, the reason why the cisterna chyli is the cutoff point for this is because it's what all of the small intestine drains into. So all of that lipid that's being picked up by the lymphatic system from digestion goes to the cisterna chyli through the intestinal ducts and meets up with all of the fluid coming from the lower body, coming from the right and left lumbar ducts into the cisterna chyli. And then from the cisterna chyli, all that fluid moves up through the thoracic duct, arcs over to the left side, and connects into the left subclavian vein, along with what's draining from the head, shoulder, and arm on that side. On the right side, all you have are the drainage from the head, shoulder, and arm on the right side, as well as the right thoracic cavity. But there's a huge difference, asymmetry in drainage, because from the cisterna chyli down, all of the lower body is draining in, because the small intestines all drain in together to the cisterna chyli. Consider this question. When you feel that you've reached an answer, hit the next button to go into the next slide, which will reveal the correct answer. Lymphatic fluid drains into the subclavian vein on either side. The lower body, everything below the cisterna chyli, drains to the left side. So it's going to go into the left subclavian vein.